Alright, my name is Yana Gritsak, and I'm doing BC 2010 number 3. The special skills you will need are entering an integral into a calculator, finding zeros on a graph, and the equations for speed and distance. The problem says, a particle is moving along a curve so that its position at time t is x of t comma y of t, where x of t is equal to t squared minus 4t plus 8, and y of t is not explicitly given. Both x and y are measured in meters, and t is measured in seconds. It is known that dy dt is equal to t e to the t minus 3 minus 1. Problem A. So it's given to us that x of t is equal to t squared minus 4t plus 8, and dy dt is equal to t e to the t minus 3 minus 1. We can find the derivative of x of t by using the chain rule. We bring down the 2 to get 2t, and the derivative of 4t is just 4, so it would be 2t minus 4. To find the speed, we need the equation. Part A says, find the speed of the particle at time t equals 3 seconds. To find the speed, we need the equation, which is the square root of x prime t squared plus y prime t squared. We know x prime t is 2t minus 4, so we plug it in, and y prime t is t e to the t minus 3 minus 1, and we plug it in. Then we plug in 3 for a value of t into here. So we get 2 times 3, which is 6, minus 4, which is 2, and 3 minus 3 is 0, and e to the 0 is 1, so 3 times 1 is 3, minus 1 is 2. 2 squared plus 2 squared is the square root of 8. Put it into a calculator and you get 2.828 meters per second, and you get 1 point for having the right answer. Part B. Find the total distance traveled by particle from 0 to 4 seconds. The equation for distance is the integral from a to b of square root of x prime t plus y prime t squared dt. So we know that time is from 0 to 4, so we put that into our values here. And we're going to have the square root of x prime t, which is 2t minus 4 squared, plus y prime t, which is t e to the t minus 3 minus 1 squared dt. You put it into your calculator, and you get 11.588 meters. Problem C. Find the time t from 0 to 4 when the line tangent to the path of the particle is horizontal. So it's asking for our slope at 0. Is the direction of the motion of the particle moving towards the left or to the right at that time? And give a reason for your answer. So we want to find the slope, which is dy dx, and we want to set it equal to 0. To find dy dx, we know dy dt over dx dt and set it equal to 0. We know dy dt is t e to the t minus 3 minus 1 over dx dt, which is 2t minus 4, and set it equal to 0. If you multiply both sides by 2t minus 4, you're going to get t e to the t minus 3 minus 1 equals 0. You put it into your calculator and graph it, and you get this. To find the 0, you're going to press second calc, go down to the 0 option, find the left bound, so you go to the left, press enter, go to the right, press enter, and get as close as you can to the value, and press enter. As you can see, for our x, it gives us 2.208, which ends up being our t. To find if the particle is moving left or right, we want to set x prime t. We want to put our value into x prime t. So we put 2.208 times 2 minus 4, and we get 0.416, which is greater than 0. So the particle is moving towards the right at time t equals 2.208. For problem B, you're going to get 2 points. 1 point for the integral and 1 point for the answer. Problem C, you get 3 points. 1 point for having dy dx set equal to 0, 1 point for finding t equals 2.208, and 1 point for the direction of motion with a good reason. And D. There is a point with the x-coordinate 5 through which the particle passes twice. Find each of the following. Number 1, the two values of t when that occurs. Number 2, the slopes of the lines tangent to the particle's path at that point. And number 3, the y-coordinate at that point, given y of 2, is equal to 3 plus 1 over e. So first, it wants us to find where x of t is equal to 5. So we set x of t, which is t squared minus 4t plus 8, equal to 5. We subtract 5 from both sides. We're going to get t squared minus 4t plus 3 is equal to 0. Factor it to get t minus 3 and t minus 1. It ends out that t equals 3 and t equals 1. To find the slope, we're going to want to find dy dx and plug in t for our values. Dy dx is t e to the t minus 3 minus 1 over 2t minus 4. So we plug in 1 first. E to the 1 minus 3 minus 1 is going to give us e to the negative 2 minus 1. 2 minus 4 is negative 2. Put it into the calculator and you're going to get negative 0.432. So that's the slope for value 1. If you plug in 3, you're going to get 3 e to the 3 minus 3 minus 1. 3 minus 3 is 0, e to the 0 is 1. 3 times 1 is 3, minus 1, which is 2. 2 times 3 is 6, minus 4, which is 2. So you get 2 over 2, and you get the slope of 1. So that's for part 2. For part 3, the y-coordinate of that point, given y2, is equal to 3 plus 1 over e. We know that y1 is equal to y3, so we should only look for y3. Since they gave us y2, all we have left is to add it to y3. We only know the derivative of y, so to find y of t, we need to take the antiderivative of y prime t, which is going to be this. So all we're going to have is y of 2 plus the antiderivative of y prime t, and the values of 2 to 3. So we're going to get 3 plus 1 over e plus the integral of 2 to 3 times, of t e to the t minus 3 minus 1 dt. When you put it into the calculator, you get 4. And you get 3 points for this problem. The first point you get for finding t equals 1 and t equals 3. The second point for finding the slopes of t1 and t3. And the third point for finding the y-coordinate. And that's all.